Okay, so now we will be taking a deeper look into each VM of my networking Capstone project. So we will start from the core router again. So this is the SSH interface for my core router, which I've logged in with PuTTY from my primary domain controller. So issue this command on the configuration mode, and then it displays us all the configuration that has been configured in this router. So we'll start off with the firewall. See, all the pings are enabled, so everyone can ping each other, and this 1195 port number is allowed because we need it for the OpenVPN tunnel, and everything else is disabled here. So interfaces, so the ETH0, which is pointing towards the internet, has the DHCP service, has the DHCP address interface because this address will be assigned from the ISP side. Then again, firewall, these are the rules for the firewall. And alright, so the Ethernet 1 interface is pointing towards the server farm, which has 10.1.1. IP address. So this will be gateway for all the server farm and server systems. And Ethernet 2 adapter is pointing towards the web server, which has 10.1.2.1 interface. So this will be the interface, gateway interface for the web server. And for the ETH3 10.1.4.1, this is pointing towards the remote router. Now here is the OpenVPN vTunnel 1 interface configured, which has a local address of 14.14.14.1. Alright, and here we go. So yeah, so from here let's talk about OpenVPN. So local address is, as I just told, 14.14.1. Now the local host, the interface address, which is pointing outwards towards the remote router, has this IP address, which is 10.1.4.1, and the local port which the tunnel will be connecting is 1195 again, and the mode is site to site. We need a persistent tunnel, and the tunnel will be over the protocol UDP, and the remote tunnel IP address will be 14.14.14.2, and the remote port will be 1195 again. And here is a shared secret key file, which both routers have it on their own, and they look into this for the password, and then they connect with the tunnel. So here is the NAT interfaces. So rule 10, which says outbound interface, is ETH0, which is pointing towards the internet, and then the source address, which is 10.1.0 network, which is the server farm, and same for the web server location, and same for the remote router locations. So for the protocols, so as I have mentioned before in the previous video, RIP is the protocol for routing that I have used in this remote router, and here are the list of networks which is configured to be in the dynamic routing, and here is a static route configured for just OpenVPN tunnel to just let them know which interface to look for, which is vTunnel 1, which is a special interface configured for OpenVPN service. And coming to the SSH service running on port 22, which allows us to connect remotely to the router from any machine. Okay, so that was for the router configuration. I'll be talking more about the build server configuration just here. Sorry, I'll talk about the centralized syslogging server. So as we can see it here, it has all the logs. If we just do clear and then tail var log secure. It gives us all the logins from the usernames from the different machines that have been done. So suppose for the CentOS 7 machine, which is our build server, there was an invalid username and invalid password for user administrator. Alright, and then again it got connected, then the connection was closed actually at from the 10.1.1.4 IP address, which is the domain controller, which we tried to do a putty session just in a minute. And here is the SSH session that got logged, that when we logged into the uh, centralized syslog server and the Spark server. So we will try to generate a log here. This is test. Okay, let's see. Actually, what we'll try to do, we'll close this session and we'll try to log in as a root. So the party, new session, CentOS 7 root. Okay, we logged in. We go here again, and there we can see there was a session logged in. We can see the time, and we can see the original time that has been here. Okay, so now about messaging server. So messaging server has been configured on OpenFire, which is open source, which has Spark, and is connected with the LDAP server, which can actually tell you which users and groups are active. Then these are the users that the OpenFile have picked it up from the Active Directory. Okay, so there are no user logged on right now, so we can try to log in as this user. And this is the secondary domain controller, which we will be able to we will be logging as another user here. Okay, so now it is on offline Peter Parker, which is offline, so we'll check if we got logged in. Okay, now so here you can see that under the group of Spark users, the user is listed, and we can now successfully chat between the users. So if we go say hub, for example, and if we go on the domain controller, we can see there's a message from hub. So this was the demonstration for the messaging server. Now the secondary domain controller has all the entries for the DNS. So in case if the primary domain controller fails, we still have the DNS running on the secondary domain controller as well, and the Active Directory services. So we have to not worry about anything related with the DNS if a primary domain controller goes off. So the another part I would like to discuss in this video is that I have done authentication from Active Directory to Linux servers. So any Linux server we can log in as any credential with the Active Directory. So let's try it here. We'll log out. We'll try to log in into our build server as an administrator. So a new session here. CentOS again. And this is configured on each and every server, so every Linux server can be logged on with the domain Active Directory credentials. So we just have to mention the full email address of the user we are trying to log in as. For example, here it is administrator@mydomain.com, and we'll enter the Active Directory password for it. and there we go, it lets us in. And we can try to do the same thing for another user as well. There we go. And I can demonstrate to you that there is no local user configured with that name. You just have to look into this file. See, there is no user configured with this name, so that this is a proof that it is configured to have the Linux server to authenticate with the Active Directory, not the local credentials. Yes, the local credentials as well if there is a local user configured on it, but this user doesn't have any local account but is still able to log into this server. Okay, so that was for the portion. And here we go for the Exchange server. Here is the list of test users that I've created mailbox for, and here is the administrator's mailbox, which I have not sent any emails to yet. Okay. Now here are all the DNS entries in the DNS server, and for reverse lookup zone there is a single entry for all the IP addresses search. And I'd like to introduce you about this node. So Snort can be run in packet sniffer mode from this machine, so that it can look into any problem happening on the network. So if we do Snort verbose, so there we go. So it looks at all the ports on the remote machines which are open, and then displays it to you so that you can know if there is any ports which were not supposed to be running on those machines. I've configured Snort as a service, so if you want to take a look at it, services MSC, there we go. So here is Snort is configured as a service, so that the service is set to automatically, so whenever the computer or the server gets boot up, the Snort services get started automatically. And I've created a custom script to create a user in Active Directory and Exchange both at the same time. Take a look into that. There we go. Run PowerShell. Say yes. Okay, so it's asking the username. Let's say test1, and assign a password. Alright, sorry. I think we have to run the script again. I think the authentication failed. I mistyped it. Administrator. Okay, so it went successfully. There was no error on this time. until then, we'll take a look into the remote router configuration. So here we can see that there's remote IP mentioned, the tunnel IP mentioned. We can ping the remote IP without any issues. We'll also be able to ping the tunnel IP. So the tunnel is up and running. Okay, so here is the OpenVPN, the same configuration as of the remote, as of the core router had. Just the difference is that the inside network for the remote router has 10.1.3.0 network. And here is the configuration for OpenVPN tunnel, which is the almost same except for the remote and the host IPs. And here is the RIP protocol, dynamic configuration of routing, and two of the static routes mentioned. Okay, so I think let's provide a new user. We'll say test2. Okay, provide the name of the user. We'll say test. Okay, this will be the user account, so the one that he logs in with. Sorry, we have to provide a password that he logs in with. Okay, we'll just give the same name as the username. We want to create mailbox. Yes. Okay, area account created. Now it is asking us for the email address, so let's type 2@domain.com. The same password as we logged on with the domain credentials. Perfect. So the user is being created. We can verify the user in Active Directory and on Exchange. So we can see there is a new mailbox created, test2, and in Active Directory we can just look up the user, test2. There we go. So now this customized script can be run on this machine, which will be releasing the work to create a mailbox and account by just running a simple script providing the name and the password. So here I would like to demonstrate you the Docker implementation that I have in this environment. So here is the Docker Swarm implementation. So here is the web server 1 and here is the web server 2. So web server 1 is the manager of the Docker, and this one is WS2 is the worker joining this swarm. So if we do docker stack ps and then the name of the stack we have deployed, which is web server at this point, you can see it is running on both WS1 and WS2, and we can actually test it on the domain controller from here, and it runs on port 4000. So WS2, and if we change to WS1, it is still going to display us the same port, and it redirects to the Docker website. There we go. So for the database server is running, and this is the login for the database Express, EM Express. So here is the database server. So it is going to be used for the database. It is going to be used by database administrators, so they have to log in with the username Oracle, otherwise there is a lot of other issues that can happen. So here is the command to start the database, and once anyone enters into the database, they have to log in with their username and password provided, and then they can run the SQL scripts to create a database, delete a database, or modify a database. So we'll gracefully shut down this instance. Okay, and then we can close it up. So the final thing I want to demonstrate is that the build server actually builds the system. So here is a test build system configured with the interface internal and which boots on the network. So here we can start. And we'll just hit cancel. Okay, so it looks for the DHCP client. Okay, it got the IP address, and then it starts loading the image from the web server, from the build server, which uses CentOS 7.5. And then finally loading the image. It might take around 5 to 10 minutes to complete this everything, and it should be afterwards. Once it is reboot up, you can log in with the credentials that uh, the system administrator will be providing you in order to log into the system. So that was all for my networking capstone project. Hope you liked it, and have a good day.